sana kayo antukin sa ating klase. So let's continue from our previous discussion and let's end our module 1. Um, Going back, yung last na discussion natin was about Morse, right? And native phonetics. So, let's say, okay, sinong gusto dyan? Sampulan natin. Kabalsa, give me a number from 1 to 31.
1 to 31, sir. 16.
Limbit ko. Sige. Si Limbit ko, nandiyan ba? Buhay ba ang iyong microphone? Wala kang microphone. Makapag-unmute ka ba? Yes, no? Kindly unmute yourself. Kaya mag-alala, wala namang blindfold at taas kamay dito. Limbit ko. Are you able to unmute yourself?
Sir.
Ayun.
Ay.
So, kindly, i-phonetics mo nga yung entire name mo. Yung Kian Limbit ko.
Paano po ni?
Using the NATO phonetics.
Infinito.
Just, sige, last name na lang. Masyadong mahaba eh. Last name na lang. Do you still remember yung NATO phonetics natin? This one? Tama na. O, game.
Yung limbit ko po.
Last name lang. Nako. Bilang tayo. 5, 4, 3, 2, 1. Okay, next. Saan maganda dito? Let's try si Mr. Antonio. Are you there? May microphone ka ba?
Hindi po sir, wait lang po, nagda-drive po sir.
May nagda-drive on. Next one. Huwag na yan, nagda-drive. Mr. Karunungan, are you there?
Present, sir.
Ayan. Kindly, i-phonetics mo ang iyong last name.
Last name. Charlie Alpha Romeo Uniform in November. November, lang. Haba po sila. Nakakalito. Charlie Alpha Romeo Uniform November Uniform November Golf Alpha November.
Ayan. Nice. Okay, next one. Hanap pa tayo ng mga Ito. Mr. Cabalsa, kindly
Hello, sir.
phonetics ang yung last name dahil may letter Z tayo dito eh.
Z, okay. Kabalza, Charlie Alpha Bravo Alpha Lima Zulu Alpha.
Yan. Kabisado nyo dapat last name nyo. Okay. Sino pa ba mga unique ang last name dito? Try natin si Vallejo. Yes, Vallejo, are you there?
Yes, sir.
Ayan, kindly do the phonetics.
Sierra Oscar Papa, Hotel India Alpha.
Last name?
Pati last name.
Mm,
Victor
syempre.
Alpha. Lima, Echo, Juliet, then Oscar.
Akala ko may nagsasabi ng Julius eh.
Pati last name mo, sir. Ako na.
Wag na.
Sige po.
Okay. So, ano lang yan? Just a review, di ba? Yung NATO phonetics natin is a standard. This is a standard for all aviation. Hindi lang aviation. Kumbaga, lahat naman is understood dito, di ba? Alpha Bravo Charlie Delta Echo Foxtrot Golf Hotel India Juliet Kilo Lima Mike November Oscar Papa Quebec Romeo Sierra. Yun nga eh. That's the problem. Walang Enye. So, ang finalo kasi dito is yung 26 letters of English lang. So, sa ano kasi, walang ginagamit na Enye sa mga phenophonetics. Kasi usually naman ang phonetics lang naman sa ano, class sa pag nagraradyo ka is usually yung ano lang naman, yung call sign nyo lang naman. And walang Enye doon. Kaya iniwasan ko sila Montaño, sila Bagagnian, dahil may letter Enye sa kanila. So hindi kasama yun. Ayan. So, please, if you're not yet familiar, please familiar yourselves with the NATO phonetic alphabet so that you would, kumbaga, hindi tayo mag-iimbento ng mga sali-salita. Let's say, Q. Imbes na Quebec sabihin mo, Q for cucumber. Nakakalito naman yun. Paano kung C? A for apple. Diba? B for Barney. H for hospital. Kanya-kanya, may sarili kang ano, Jun. Na-miss ko tuloy yung estudyante ko na third year, si Junel. So, huwag kayong mag-iimbento ng phonetics, ha? O kapag may mga tumawag din sa inyo, for example, mga prank calls, hindi naman prank call yun. Yung mga nangunguha ng number sa mga ano, yung sa form. Di ba usually tumatawag yan pag mga credit card ganyan. Pag magpo-phonetics kayo, lituhin nyo. Ituloy-tuloy nyo. For example, kay Cabalsa, pag sinabing siya, tinanong yung, paano po spell yung name nyo? So, Juliet, Uniform, Sierra Tango, India, November, Echo, Charlie, Alpha, Bravo, Alpha, Lima, Zulu, Alpha. Bahala na kayo. I will not repeat it again. Ayan, di ba? Malilito sila. So, especially kapag hindi ka familiar, malilito ka talaga. Pero kapag nasa aviation industry ka naman, hindi ka dapat nalilito. Especially kung magpipiloto kayo. Kung magpipiloto kayo, kahit naman hindi kayo magpiloto kailangan talaga kabisado nyo. It's a mandatory na familiar kayo dito. Tapos yun sa numbering system din natin, of course. Ang number natin, ganyan. 1, 2, 3. Power, diba? 4, pero dapat power. Fifth. 5, 6, 7, 8, 9, or 0. Now, let's talk about ano naman, sa radio telephony naman tayo. Sa radio telephony, it's different from radio telegraphy, di ba? Yung radio is the means to, or it is the medium. That's the medium to transmit the information or data from point one, from point A to another. So, in terms of ano naman, radio telegraphy, it is through Morse, di ba? Through Morse, kasi telegraphy. Now, telephony naman tayo. So, papasok naman tayo sa mga landlines nyo. Same yan sa mga landlines nyo. So, the means of a sound or audio by radio. In contrast to radio telegraphy, yung sa telegraphy is we use telegraph signals. And yung telegraph signals na yon, to be exact, are yung Morse code. Yes? Of course, that's Morse code. And, or, dito, is or video transmission. Sa video transmission kasi iba naman 'yan, 'di ba? Meron ba kayong nakita na na landline na may video? Parang wala naman, no? Iba pa 'yun. Ibang technology naman siya. Now, where two-way radio systems is arranged for speaking and listening at a mobile station, and where it can be interconnected to the public switch telephone system. The system can provide mobile telephone services. So, one of the pioneers ng landline natin is si PLDT, right? Long for Philippine Long Distance PLDT transmission. So, si PLDT yan. Another company it's a company well known for landlines, di ba? And sabi ko nga sa inyo, iba-ibang types of transmission natin, class. So, for example, mayroon kayong Wi-Fi na fiber, it really doesn't need a landline for it to work compared sa DSL. Kapag may DSL kayo, automatic may landline kayo kasi doon kumo-connect yung modem nyo. Unlike yung tawag dito, yung fiber, it doesn't need a landline. It's optional if you want to add. Now, radio telephony procedures. Dito tayo. Also, on-air protocol and voice procedures. Paano ba? Sorry, busog. Includes various techniques used to clarify. So, used to clarify, simplify, and standardize spoken communication over two-way radios in a use of armed forces, civil aviation, police and fire dispatching systems, citizen band radio, and amateur radio. Now, class, this is all standardized. Kumbaga, di ba? For example, sa phonetics na lang. Walang nagpo-phonetics na magtaka ka police, sinabi niya B for Barney. Di ba? C for Charot. Walang ganun. So, lahat yan is standardized in which understandable yan either mapa civil aviation ka or armed for or in the military ka. Dalawa lang naman yan sa sa aviation. It's either you're from the civil aviation or you are from the military aviation. Now, voice procedures communications are intended, class, to maximize clarity of spoken communication and reduce errors in verbal messages by use of an accepted nomenclature. Ayan. So, dito papasok yung kanina na sinabi ko sa inyo na pina-phonetics ko sa inyo. So, if ever nag-phonetics ka ng ganun, maiintindihan ng lahat yan and it's very clear. Kasi if you're trying to do your own phonetics, let's say, I for eyes, pwede siyang E, di ba? E, eyes, o yellow eyes, ICE, or EYES. Q for cucumber, or C for cucumber. Ano pa ba yung mga nakakalitong words? Basta, it's not necessary, for example, lahat naman may intindihan yung word na yon, di ba? Now, it consists of signaling protocol such as abbreviated codes like the CB radio 10 codes. Ito, yung 10 codes. We'll be discussing this one. We also have yung Q codes in amateur radio and in aviation, police codes, etc. and jargons. Ano may mga jargons na yan? For example, LTE, di ba? Alam natin na LTE, pero ano ba meaning nun? Long-term evolution. Diba? Now, let's talk about yung 10 codes. So, 10 codes is officially known as to be 10 signals. So, a brevity codes used to represent common phrases in voice communication. So, common phrases in voice communication, particularly by whom? by law enforcement and citizen band or yung mga CB radios natin. Now, yung Q codes naman class, it is a standardized collection of 3-letter codes, all which starts with the letter Q. Kaya nga Q codes. Now, it is an operating signal initially developed for commercial radio telegraph communication and later adopted by other radio services, especially amateur radio. Now, meron tayo class na tinatawag na radio facsimile. Wait, lumipat. Ayan. Radio facsimile. Radio fax, also known as weather fax. Yung HF fax class here. HF fax. Due to its common use on shortwave radio, is an analog mode for transmitting monochrome images. So, ito yung I am not sure if it's still used up until today, mga fax machines. Anyway, we'll not be diving deep too much dito sa na to because we'll be focusing on a different one. So, it was the predecessor to a slow scan television or SSTV, is a picture transmission method used mainly by amateur radio operators to transmit and receive static pictures via radio in monochrome or color. Next, prior to the advent of the commercial telephone or telephone line, this one, or titawag nating fax machine, it was known more traditionally by the term radio facsimile. Now, facsimile machines or yung mga tinatawag nating fax machines were used in the 1950s to transmit weather charts across the United States via line first and then internationally via HF radios. So, before a flight kasi class, you would need to have yung yung weather forecast. So that's why for example, pupunta ng Lubang. Hindi basta-basta pwede pumunta ng Lubang na let's say good weather naman dito. Along the way naman may bad weather or pangit yung visibility. Of course, that's a no flight pa rin. So weather plays an important role here. So yung means ng pag-transmit ng natin ng mga weather logs, weather data or saan papunta yung wind and so on and so forth. Back then in the 1950s, utilizes yung mga fax machines. So radio transmission of weather charts provided an enormous amount of flexibility. So, paano ba siya sa flexibility? Of course, di ba, since you already have the information of the predicted weather, you would have other ways to navigate. Kasi nga, natin dyan, ang standard natin dyan is we don't go through weather. We try to go around the weather. You don't take risk, more risk by entering a weather rather than sa umikot ka na lang, even though mas matagal siya, at less minimal risk naman. Now, it became more flexible to marine and aviation users. For now, they have the latest weather information and forecasts at their fingertips to use in planning voyages. Wala pa naman kasing class na yung mga 1950s, wala pa naman yung tinatawag na weather radar. Kasi today, weather radar is installed on most all of the modern aircrafts. So, kahit yung mga Cessna class, yung G1000 or yung S variant ng Cessna, Basta ano siya, it could be a full glass cockpit na Cessna 172 or a tandem. Pag tandem yun class, half and half. Right side naka-glass and then left side naka-analog. So, sa ganun naman is naka-integrate na yung weather radar. Pero if you look back dun sa older aircrafts, not all aircrafts are equipped with a weather radar. So, kung ano man yung nakuha mo na weather at that moment, yun na yung talagang meron ka. So if ever there are any changes, it's up to the pilot skills to navigate through weather. Compared ngayon, isipin niyo yung technology ngayon na we're able to see through yung mga clouds and we would know where to go to. Ayan. Kasi doon sa weather radar, makikita mo kung saan ka pwedeng makadaan, saan mas konti yung precipitation and so on and so forth. Now, RadioFax relies on facsimile technology where printed information is scanned line by line and encoded into electrical signals which can be transmitted via physical line, to yung DSL, or basta yung phone line, or radio waves to remote locations. Ayan. So, if you haven't seen a fax machine, ang fax machine kasi class, meron na ba sa inyo nakakita ng fax machine? Ayan, si Cabalsa nakakita na ng fax machine. So, para lang siyang printer class, mukha lang siyang printer. And ipapasok mo yung yung data. Parang ini-scan niya, line per line. Parang nga lang nagpiprint ng pabaliktad. May sulat na, pero pagdating naman dun sa kabilang side, wala, ganun pa rin naman. Ini-scan lang. Tapos automatic yan, once na dun sa other side, marireceive nila yung fax. Ipiprint naman kung ano yung na-scan. Ganun siya. Now, today, radio fax data is available via FTP. FTP downloads from sites in the internet, such as one hosted by the NOAA, or National Oceanic and Atmospheric Administration. So, maraming sites na class yung for weather. Hindi na tayo nag-rely sa, for example, yung Pag-asa na lang, di ba? Si Pag-asa, nag-rely din yan sa ibang countries such as Japan. Yung Japan Meteorological something. Nalimutan ko yung tawag. So, nag-rely tayo sa mga information doon for weather forecasts. Now, radio fax transmissions are also broadcasted by NOAA from multiple sites in the country at regular daily schedules. Now, radio weather fax transmissions are particularly useful to shipping, ito, yung marine natin, where there are limited facilities for accessing the internet. So, yung natin, yung ganyan is of course through internet. Same lang naman din yan, parang radio fax din siya, but mas high-tech nga lang siya. Now, in radio fax transmission, radio fax is transmitted in a single sideband with a refinement of amplitude modulation. So, AM siya. Kasi nga, di ba, sabi kanina, HF. So, most likely, nasa AM yan. The signal shifts up or down and a given amount to designate white or black pixels. So, di ba alam naman natin ng amplitude modulation. Sine wave lang naman siya. Now, a deviation less than that for a white or black pixel is taken to be a shade of gray. So, sa amplitude modulation natin, if we look at this one, 0, may plus 5, minus 5 ka. Nagva-vary yung, nagva-vary siya ng amplitude. So, ganyan. But yung niya, the distance from here to here is equal. It's always equal. Nagbabago lang is yung mismong amplitude niya. So, pwede siyang humaba, pwede siyang umikse, and so on and so forth. Ganyan. Now, the signal shifts up or down a given amount to designate white or black pixels. Now, a deviation less than that for a white or black pixel is taken as a shade of gray. So, for example, ito, so positive 5, it could be designated to be white. And this one is black. And then, if hindi siya nag-peak, pwede siyang maging gray. Depende yan sa signal. So, the higher it is, the lighter the gray would be. And then, kapag dito naman sa baba, let's say, pag ganyan siya, mas malayo siya sa black, the lighter the gray is, or mas malapit siya sa black, the darker the gray, up until maging black siya. Ganun lang yun. Now, usually 120 lines per minute are sent. So, 120 lines per minute, hindi siya ganun kadami. Parang ano lang siya, class, kung naabutan niyo yung mga telephones from back then, yung mga 3310, ano lang kasi yon 2G. We're not capable of transmitting video pa nun. Kumbaga parang landline lang siya but mobile. Ang nangyayari niyan is you're limited to 160 characters to send. Above that one, doble na, 2 piso na yung text. So, ganito is for sa radio fax natin, bilang it has an enormous amount of data stored at it, 120 lines lang yung maximum capacity niya. Kasi nga 'di ba, color coded pa siya. Yung sa naman, yung mga text naman is ano lang naman siya, letters lang naman and symbols. Walang kailangan ni portrait. Now, in terms of history naman, class, maging historian na naman tayo. In 1911, year 1911, this was the first amplitude modulator for fax machine is patented, permitting transmission via telephone lines. Now, in 1913, si Bellins, Bellinograph, yan. Isang fax machine din yan kay Edward Bellins called the Bellinograph. Year 1922 naman, class, the first transatlantic facsimile service was provided by RCA. So ito was already, yung HF radio has already been established. Now, from 22 to 25, RCA faxes photos across the Atlantic in 6 minutes. So, ganun siya kabilis. AT&T and RCA and Western Union develop a high-speed fax system. Dr. Arthur Korn facsimile system is used to transmit by radio a photograph of Pope Pius XI from Rome to Maine, USA. The picture is published the same day in the New York World newspaper, a major feat in an era when news pictures crossed by the oceans, or yung news pictures cross the ocean by ship. So instead of yung nag-utilize pa sila ng barko para makapag-ship ng picture, nagawa nila na mag-ship ng picture through fax. And it only took it 6 minutes from yung mag-cross from the Atlantic. Now, in 1925, ito, kilalang company naman to in the United States is the AT&T Wire Photo starts operation. In 1926, same goes with RCA Radio Photos starts operation. Next is yung kay Rudolph Hell, introduced the Hellschreiber. So, same, lahat naman to class, fax machine lang naman lahat din to. Iba-iba nga lang yung rendition. Now, in 1927, the first Siemens Carolus Telefunken facsimile between Berlin and other European cities. In 1937, the first broadcast of a radio fax newspaper in Minneapolis, St. Paul area. In 1939 naman, ito, si W9XYZ, Louis, delivers a first daily newspaper from Radio Facsimile. More than 1,000 US households are experimentally equipped with fax receivers that electronically print morning newspapers overnight. Ayan. Diba? Isipin nyo, libre ang newspaper. Automatic na lang piniprint nung fax machine. Now in 41 class, fax is enlisted by the military to transport and to transmit maps, orders, and weather charts during the World War II. So, kaya nga sabi nila that the World War II was won through radio. So, aside from hacking, they also utilized radio to give out tactics, 'di ba? They were able to find out what the plans of the Nazis were and do a countermeasure. So everything was done through radio. So diyan din nauso yung mga pag-encrypt ng mga data. So ito lang naman is another rendition of a fax machine. So up until here, 1960, the first SSTV test transmission in the USA and in Germany in 1972. Now, next one class is yung ano natin. Meron na tayong radio telephone, radio telegraph. Now is radio teletype. Now, what is a radio teletype or RTTY? Is a telecommunication system consisting originally of two or more electromechanical teleprinters in different locations connected by radio rather than wired link. Ayan. So, wireless to. Now, these machines are superseded by personal computers or yung mga PCs na meron tayo ngayon, mga ginagamit nyo. PC running softwares to emulate teleprinters. Evolved from earlier landline teleprinter operations that began in the mid-1800s, the U.S. Navy Department successfully tested printing telegraphy between an airplane and ground radio station in 1922. So, eto class, dito is nagpo-foregoing yung tinatawag nating, ACARS. Kasi yung ACARS can actually send out information and automatically being printed dun sa ground station, sa mga base station ng mga airlines. Later that year, the Radio Corporation of America successfully tested printing telegraphy via their Chatham, Massachusetts radio station to the RMS Majestic. The commercial RTTY systems were in active service between San Francisco and Honolulu as early as April 1932 and between San Francisco and New York in 1934. Now, the U.S. military used the radio teletype in 1930s and expanded during World War II. Teleprinters were replaced by computers running teleprinter emulation software. Ayan. So, yun yung mga nakikita nyo sa mga movies na parang ang daming type and then biglang mapiprint sa iba. So, yun. Now, the term radio teletype is used to describe both the original radio teletype system, sometimes described as BODO, as well as the entire family of systems connecting two or more teleprinters or PCs using software to emulate teleprinters over radio, regardless of alphabet, link system, or modulation. Now, the Bodo code, and Bodo, is an early character encoding for telegraph invented by Emile Bodo in 1870s. Ito yung nakikita nyo. Ito. Yan. Yan yung class. It was the predecessor to the International Telegraph Alphabet number 2 or the ITA2, the most common teleprinter code in use until the advent of the ASCII code. Ayan. So hopefully ako ba magiging instructor nyo doon? Anyway, sa GEL2 kasi. So meron tayong ASCII code. So meron tayong mga binary codes. If you're familiar with binary codes class, we have binary codes which is ones and zeros, kaya nga binary. Ones or zeros lang yan. Ba't hindi buo yung zero dito? Ayan. So, meron din tayong mga octal number, hexa, and deci. So, marami yan. Meron din tayong tinatawag na ASCII codes. So, sa ASCII codes naman kasi is, yan yung mga nababasa ng mga PCs na codes, yung mga ASCII codes. So, for example, nag-type kayo sa mga keyboards nyo. Ayan. Automatic yan na co-convert yan into ASCII codes. And then, lumalabas siya sa mga monitors nyo. Ayan. So, ASCII codes. Now, each characters in the alphabet is represented by a series of 5 bits sent over a communication channel such as telegraph wire or radio signals. Same lang din yan. Isipin nyo ngayon, class, pag nag-type kayo sa printer nyo, nag-type kayo sa keyboard nyo, mako-convert siya into codes or yung 5-bit codes. Technically, ASCII codes. And then, once na tinype nyo yan, lalabas yan. Meron kayo interface, of course, yung monitor. Makikita nyo yan. And then, pwede nang ma-print yan over wirelessly. Kumbaga parang may wireless na printer kayo, but in fax form. Yan. Then, we have yung tinatawag na LORAN or yung Long Range Navigation. So, a LORAN is a system based off a hyperbolic radio navigation. A system was developed during the 1940s as LORAN systems was developed during the 1940s as marami yan, class. Meron ka LORAN A, LORAN B, LORAN C, and so on and so forth. So, as LORAN A and has undergone many developments. The current version is the LORAN C. So, operating in the low frequency range of, take note class, 90 to 100 kilohertz. The system comprises ground transmitters and monitoring stations. So, please take note na, again, yung old technology kasi class, during the 1940s naman, we cannot utilize naman talaga yung mga higher frequency because it is very hard to generate those types of frequencies, yung mga matataas na frequency. So, we heavily relied dun sa mga low frequencies. So, for example na lang yung mga submarines. Submarines actually utilizes yung mga low frequencies. They don't usually use yung mga higher frequency because it's useless. They're underwater. And the form of communication that they can have is through ground wave lang. Now, next is the LORAN C system has a typical range class of 1,000 nautical miles and an accuracy of better than 0.25 nautical miles. This is through navigation class. This is not radio communication. Voice communication pala, sorry. or 460 meters yung accuracy niya. Now, in the defined coverage areas. Now, transmitters are grouped together in chains, thus providing a two-dimensional position fixing capability. Now, these patterns are formed in various ways to master and secondary station. So, again, meron kang master and secondary stations. For example, this one, you have your master here and then two secondary stations between it na nakalink. So, interlink yan. Just look at the na lang. Ano ba modern counterpart niyan? Just look at Starlink na lang, diba? So Starlink, there are series of satellites linked with each other to form a nest. Kumbaga parang nest siya. So that we'll be able to access the internet kahit nasan tayo. Kahit nasan tayo, we would be able to connect to one satellite and that satellite is connected with each other. Ayan lang, that's just the chain. The patterns are formed in various ways by master and secondary stations. Ayan. Now, how does it operate? Now, Lorentz chains are organized in a master and secondary configuration. Each master has at least two associated master station. Secondary station. In some cases, there are 5 secondary stations in a chain. Ayan. The elapsed time between receiving pulses from the master station and 2 or more secondary station is used to determine a unique position. Pulses are formed as variable amplitude sine waves. Ito class, this is what we call sine wave. Ayan. Taas baba. And looking at it, class, this is a sine wave. Is it amplitude modulation or frequency modulation? This one. Does it look like an amplitude modulation or frequency modulation? Ayan, kung sino man yung sumagot. Yes, that is correct. Amplitude. It's because yung yung amplitude, yung highness and lowness niya is not constant. Kumbaga nagfa-fluctuate siya up and down. Now, pulses are formed as variable amplitude sine waves with fixed frequencies. The pulse duration is 270 milliseconds, representing 27 cycles of 100 kilohertz carrier wave. Now again, going back yung sa cycle natin, 'di ba? Ang cycle natin sa per second is ilang hertz ba siya? Ilang cycles ba nangyari sa isang second? So for example, ito, 3 cycles to, ibig sabihin meron kang 3 seconds diyan. Or in terms dito sa natin, sa Lorentz natin is 3 millisecond. So tama, 27,270. So kung 27, so 0.3 millisecond lang pala to. Kasi if we're having 27 cycles at 270 ms, diba, times 10 siya. So dito, yung sa is bibilangin mo kung ilan yung time. So meron kang 270 milliseconds representing 27 cycles of the 100 kilohertz carrier wave. Now, this unique pulses provides a recognizable signal and ensures that the majority of the pulse bandwidth is confined to the frequency range of 90 to 110 kilohertz. Now, the intention of the Lorentz is to only use 2 ground waves for navigation purposes only, because sky waves filter out the pulse timing techniques. Ayan. So, kasi yung sa sky wave, meron tayong ionosphere. Now, yung ionosphere naman actually disrupts yung mga signals if you won't be able to transmit at a proper frequency. Now, operation aspects associated with Lorentz is one, electromagnetic interference affecting the signal. Example, yung mga power lines natin. As well as, of course, yung weather if it's a stormy day. Loss of one station affects the area of coverage. Area yan. Area of coverage. Kasi nga, di ba, kulang yung link. So, for example, meron kang master, usually dalawa siyang secondary. Naka-daisy chain siya. Now, if ever nasira to or nawala yan, kulang yung ano mo, so mas matagal yung transmission. Next is local weather conditions, particularly electrical storms affecting the signals. Again, lahat naman yan class affected ng ano, hindi friend ng radio ang storm. That's why, anong dahilan ng mga estudyante? Hindi lang mga estudyante, but including instructors, kapag naulan at may synchronous klase or classes. Ano ang glaring na dahilan? Mabagal net. Or, music sa ears nyo, asynchronous tayo class, maulan, walang internet. Diba? Music sa ears niya pag nag-announce na si sir or si ma'am ng ganun. It's because naapektuhan talaga kahit yung ano lang the rain itself, kahit walang thunderstorm, the rain itself actually affects the signal. Kasi meron tayong tinatawag na noise to SNR. Hindi to yung bilihan ng pizza. Hindi rin yan yung mall. So, SNR is signal to noise ratio. So, ang signal natin naapektuhan siya through noise. So, kapag masyadong noisy, kahit na mga sasakyan man lang, nakaka-apekto yun class dun sa speed of transmission. So, especially kapag umuulan ng malakas, kahit walang thunderstorm, mapapansin nyo mabagal yung internet. At ang pinaka-apektado dyan is yung dalawang klase ng transmission. First is yung broadband. Next is yung DSL. Itong dalawa, na madaling maapektuhan niya ng ulan. Mabilis na maapektuhan siya. Mabilis na bumabagal. Compared sa sa tawag dito. Compared siya sa fiber, ang fiber not so much. So kung naka-fiber kayo, swerte kayo. 'Di ba? Kasi mabilis na nga yung transmission, hindi pa masyado siyang naapektuhan ng mga disturbances, mga ulan-ulan na yan. Tuloy pa rin ng klase, sabi nga ni sir or ni ma'am. Now, the Lorentz group ground equipment, of course, sabi ko nga sa inyo, it's a chain of the master and secondary. Master and secondary transmitting stations are located at strategic places to provide the required geometry for obtaining navigation information. Now, transmit towers are typically 700 to 1,300 feet high and radiate for around 400 to 1,600 watts of power. So, kasi nga, malaki yung kailangan niya makover na distance. That's why we are utilizing a lot of power, 400 to 1,600 watts of transmit power. Now, the master and secondary stations are formed in groups known as chains. Wait lang, class. Okay, going back. The Lawrence airborne equipment. Now, the airborne equipment comprises ito. So, ito yung mga naka-equip sa aircraft. The antenna receiver and control display unit or the CDU, yun yung mismong instrument mo. The antenna is often shared with the ADF sense and loop antenna. Bakit? Tingin nyo, bakit siya nakashare sa ADF na antenna? Why? Let's go back here. Ito class. Yung frequency range niya, 90 to 100 kilohertz. Pwedeng gamitin yung ADF sense and loop antenna for transmission dun sa Lawrence. Now, the Lawrence chains all transmit at 100 kilohertz. The receiver searches for the master station to track and tracks the secondary signals. This is achieved with the phase-locked loop process ang sa loop antenna. Kaya nga 'di ba sa ADF natin, if nakinig kayo kanina, sa ADF natin meron kang loop antenna. So yung loop antenna, doon siya nagpo-point. Doon niya nalalaman. Yung sense, nasa-sense niya na may signal, and then yung loop is saan siya pupunta. Ayun. Same goes with this one sa Lawrence. So, dito, all the chains transmit at 100 kilohertz, and the aircraft in range of more than one chain will receive pulses for many stations. Depende again kung ilan yung secondary stations natin. Now, the receiver has to be able to identify specific chains by their mission delays. So, of course, di ba, ang transmission natin class, especially for at a lower frequencies, is may delay yan. Now, once identified, the receiver determines which chain is providing the strongest signal and which is providing the best navigation solution. Accurate timing signals are used to recognize the unique Lawrence pulse shape. Once acquired, the receiver needs to identify the third peak of the pulse. This peak has the highest rate of change with respect to the 8 pulses. Identification of the third peak is determined by measuring zero, crossing, hirap naman anuhin ito, crossing and amplitude, ay ano ba yan? Tama, amplitude with, ba't ba hindi ko nalang burahin? Wait lang class, burahin natin. Ayan. Better. Now, zero crossing and amplitude growth with the pulse. Now, aircraft communications and navigation systems, the receiver also has to be able to reject a large amount of interference and atmospheric noises. A navigation computing function can be provided or enhanced operation for the system. The chain details such as yung latitude and longitude, of course, kailangan natin ng dalawa na to for us to get the coordinate, yung exact location mo. Stations, GRI, and secondary delay times are all stored in a database. Now, correction can be applied for known propagation differences over sea, land, and ice. If the receiver is receiving pulses for more than one chain, it is possible to calculate the average position, typical control display unit, used for hyperbolic navigation. Ito class naman kasi yung Lawrence is hindi na siya masyadong nagagamit. It's almost the same as ADF, yung Lawrence, because today may tinatawag na tayong ganito. Diba? Yung GPS. So yung GPS or the Global Positioning System is the one is utilized for long-range navigation. Hindi na yung LORAN. Ayan. So, time check 2:41. That's actually is the last slide natin. Ayan. Any question? Nandiyan na ba si Salvador at si Malinis? At saka si Francisco? Diyan na kayo? Wala. Wala. Okay, wala. Alright. So, that concludes our module 1 for sa Arcome. Wait lang.